Hello dear students, all of you welcome to Vidyan classes. Today we will discuss inverse of a matrix by elementary operations. Inverse of a matrix by elementary operations. There are two types of elementary operations. First, row operation. Second, column operations. There are two types of elementary operations. They are row operations and column operations. Steps to find inverse of a matrix by elementary row operation. Operation or transformation or transformation. There are two types of elementary operations or transformations. They are row operation and column operation. Steps to find the inverse of a matrix by elementary row operations. Steps to find inverse of a matrix by elementary row operation. Let capital A be a square matrix. Step 1, write A is equal to I into A, where I and A are of same order. In first step, write A is equal to IA, where I and A are of same order. Step 2, apply a sequence. Apply a sequence of elementary row operations on capital A is equal to I A. Apply a sequence of row operations on A is equal to IA till we get I is equal to B into A. That implies B is equal to A inverse. In first step, you write A is equal to IA, where I and A are of same order. Apply a sequence of elementary row operations on A is equal to IA till you get I is equal to BA. When you get I is equal to BA, that implies B is equal to A inverse. Clear? In first step, write A is equal to IA, apply a sequence of elementary row operations on A is equal to IA till you get or we get I is equal to BA. If I is equal to BA, we call B is equal to A inverse. Example, find the inverse of the matrix having elements 2, 3, 4, 5 using elementary row operations. Find the inverse of the matrix using elementary row operation. Solution. Let capital A be the matrix having elements 2, 3, 4, 5. In first step, write A is equal to IA. Write A is equal to IA. In row operation, you write A is equal to IA. In column operation, you will write A is equal to AI. Write A is equal to IA. Or A means it is a matrix having elements 2, 3, 4, 5. I and A are of same order. It is a matrix of order 2. So I will be the unit matrix of order 2. Clear? It is A, it is I, it is A. Apply a sequence of elementary row operations on A is equal to IA. We will apply the row operations on A is equal to IA to get I is equal to BA. That means A changes to I changes to B. When a sequence of elemental row of operations are applied, A will be I will be B. So that B is called the inverse of A. That means A changes to 1 0 0 1. First change, rough change the elements of first column of A, elements of first column to 1 and 0 using row operation. Using row operation, change the elements of column 1 as 1 and 0. Applying row 1 replaced by 1 by 2 row 1. It gives row 1 changes to half of row 1. That is 1 half of 2 is equal to 1, 3 by 2. There is no change of row 2. Simultaneously, we will apply R1 replaced by half of R1 on the unit matrix in the right hand side. 1 into half, that is equal to half, 0, 0 and 1. Applying R1 replaced by half of R1 on A in the left hand side, it gives 1, 3 by 2, 4, 5. In the right hand side of unit matrix, it gives half, 0, 0, 1. Next, we will find the columns of we will find the elements of the column 1 as 1 and 0, 4 will be 0. Applying row 2 replaced by row 2 minus 4 times of row 1. 4 minus 4 times of 1, it will be 0. Since the elements of column 1 will be 1 and 0. To get the unit matrix I. On the left hand side, it gives, there is no change of first row, 1, 3 by 2, 4 minus 4 times of 1, that is equal to 0, 5 minus row 2 is replaced row 2 minus 4 times of row 1. Row 1 means 3 by 2. It gives 5 minus 6, that is equal to minus 1. It gives minus 1. In the right hand side, half minus half, row 2 means that is 0, row 2 will be changes to row 2 minus 4 times of 0 minus 4 times of half, that is equal to minus 2. There is no change of row 1. It is half 0. 0 will be minus 2. Since R2 is replaced by R2 minus 4 times of R1. 1 minus 4 times of 0, that is equal to 1. It will be 1. Clear? R2 is replaced by R2 minus 4 times of R1. 4 will be 0. 5 by 2 will be minus 1. 0 will be -2, 1 will be 1 into A. Clear? Next, we will convert these elements of column 2 as 0, 1 to get the unit matrix 1. The first column 1, 0. The second column will be 0, 1. Apply row 2 replaced by -1 into row 2. It gives row 2 is replaced by -1 into row 2. No change of row 1, that is 1 and 3 by 2. It is 0 into -1, 0, -1 into -1, that is equal to 1. In the right hand side, 0, 2 and -1 into A. Row 2 is replaced by, we have to find out this element will be 0, this element will be 1. So row 2 is replaced by -1 into row 2, -1 into -1, that is equal to +1, and it is 0 into -1, that is equal to 0. The right hand side, -2 will be 2 and 1 will be -1. Next we will find out the element which converts 3 by 2 will be converted to 0. Apply row 1 replaced by row 1 minus 3 by 2 of row 2. It gives row 1 is this minus 3 by 2 times of row 2, it gives 1. 3 by 2, 3 by 2 minus 3 by 2 minus 3 by 2 into 1, that is equal to 0. There is no change of row 2. In the right hand side, half minus 3 by 2 into row 2, 3 by 2 into row 2. The elements of row 2 is 2. It is a minus 5 by 2. It is a minus 5 by 2. Clear? Half minus 3 by 2 into 2. R1 is replaced with 3 by 2 minus 5 by 2. 0 minus 3 by 2 minus and plus, that is it, 0 minus 3 by 2 into minus 3 by 2, that is equal to plus 3 by 2 is equal to 3 by 2. It is 3 by 2. There is no change of row 2, that is 2 minus 1. Clear? Clear? Into A. Or 1, 0 is the unit matrix. 1, 0, 0, 1 is equal to matrix minus 5 by 2, matrix having element minus 5 by 2, 3 by 2, 2 and minus 1 into A is the form of I is equal to BA. Using the elementary row operation, a sequence of row operation, not a particular row operation, a sequence. First we apply this operation, second we apply this operation, third we apply this operation, fourth we apply this operation. So it is a sequence of operations. It takes the form of I is equal to BA. Therefore, A inverse is equal to B, which is equal to minus 5 by 2 minus 5 by 2, 3 by 2, 2 and minus 1. The inverse of this matrix is minus 5 by 2, minus 1, 3 by 2 into 2. So A inverse would be is equal to this. Either A inverse equal to this. A is equal to this matrix, A inverse equal to this matrix. These calculations are rough. Clear? Are you clear? Okay. Next steps to find the inverse of a matrix by elementary column operations. What are the steps to find the inverse of a matrix by elementary column operations? Let capital A be a square matrix. Step 1. Write A is equal to AI. A and I are of same order. A and I means unit matrix are of same order. Apply a sequence. Apply a sequence of elementary column operations on A is equal to AI till we get I is equal to AB. Apply a sequence of elementary column operations on A is equal to AI till we get I is equal to AB. That means A changes to unit matrix I and the unit matrix in the right hand side changes to B. If I is equal to AB, that implies B is equal to A inverse. There are two steps. It is step 2. In step 1, write A is equal to AI, where A is a square matrix. A and I are of same order. Step 2, apply a sequence of elementary column operations on A is equal to AI till we get I is equal to AB. I changes to A changes to I and I changes to B by the application of column operations. Clear? First we will write A is equal to AI, where A and I are of same order. Apply a sequence of elementary column operations on A is equal to AI till we get I is equal to AB. Example, find the inverse of the matrix. Matrix means square matrix. Rectangular matrix has no inverse. Find the inverse of the matrix having elements 1, 2, 3, 7 using column operations. Find the inverse of the matrix having element 1, 2, 3, 7. It is a square matrix of order 2 using column operations. Solution. Let capital A, let capital A be the given matrix having elements 1, 2, 3, 7. In first step, write A is equal to AI. A is equal to, write A is equal to AI. In a row operation, we write A is equal to IA. In column operation, we write A is equal to AI. Or A means it is a matrix having elements 1, 2, 3, 7. A remains the same. A and I are of same order. It is a matrix of order 2. So I must be the unit matrix of order 2. Now we will change this matrix using column operation to I, and I changes to B, and B will be the inverse of A. Apply column operation. First we will change rough. In column operation, first you change the elements of row 1 as 1, 0. Then change the elements of row 2 as 0, 1. So that the left hand side will be a unit matrix. Since A will be changes to unit matrix and I changes to B. In column operation, first change row 1 having elements 1 0 and row 2 having element 0 1 using the column operation. Using column operation. Using column operation. In LI side of A. In row operation, we change the columns. In column operation, we change the rows using column operation. We change the elements of row 1 as 1 and 0. Here 1 is present. We will change the element 2 as 0. Apply column 2. It will be 0. Column 2 is replaced by column 2 minus 2 times of column 1. In column operation, we will change the elements of row 1 as 1 0. In row operation, we will change the elements of column 1 as 1 0. Apply column 2. Apply C2, that is column 2. Replaced by column 2 minus 2 times of column 1. It gives the left hand side. There is no change of column 1. It is 1 and 3. 2 minus 2 times of 1, that is equal to 0. 7 minus 2 times of 3, that is equal to 1. Clear? Now we will change the unit matrix in the right hand side using this operation. 0 minus 2 times of 1, column 2 will be column 2 minus 0 minus 2 times of column 1 remains the same, 1 0. Column 2, 0 minus 2 times of 1, that is equal to minus 2. 1 minus 2 times of 0, that is equal to 1. Clear? Simultaneously, we will change A and I. A in the left hand side, I in the right hand side using the same operation. Clear? Row 1 changes to 1 0. Now we will change row 2 as 0 and 1. Apply column 1. Column 1 minus 3 times of column 2. It is the rough. Apply column 1 replaced by column 1 minus 3 times of column 2. The left hand side. There is no change of column 2. 1 minus 3 times of 0 or 1 minus 3 times of 0, that is equal to 1. 3 minus 3 times of 1, that is equal to 0. 0 1. Now the elements of row 2 are 0 and 1 using column operation. Simultaneously, we will change the right hand side having element 1 minus 2 0 1. There is no change of column 2, no change of column 2, minus 2 1. 1 minus 3 times of column 2, that is equal to 3 into 2 is 6 plus 1, that is equal to 7. 0 minus 3 times of column 2, that is equal to minus 3. Clear? Clear? Okay. Is the form of I is equal to AB implies B is equal to A inverse is equal to B. If I is equal to AB, by definition it implies B is the inverse of A. Inverse of A is equal to B. Here B is equal to 7 minus 2 minus 3 1. Clear? Find the inverse of the matrix using column operation. It is a rough. In column operation, we will change the row elements as 1 and 0. Then we will change the elements of row 2 as 0 1 using column operation. Similarly, in row operation, first we will change the elements of column 1 as 1 0, then column 2 0 1 in reverse order. Clear? Write down. Next, a note on row matrix, row operation and column operation. Apply one or more row or column applying one or more elementary row or column operations on A is equal to IA or A is equal to AI if all are zeros, if all are zeros in one or more rows or columns, if all are zeros in one or more rows or columns of the matrix, capital A on LI side, then A inverse does not exist. Applying one or more elementary row or column operations on A is equal to IA. For a row operation, we write A is equal to IA. For a column operation, we write A is equal to AI. If all are 0 in one or more rows or columns of the matrix capital A on LI side, then A inverse does not exist. For example, find the inverse of the matrix having elements 3, 4, 9, 12. 3, 4, 9, 12. Find the inverse of the matrix having elements 3, 4, 9, 4. Solution: let capital A be the given matrix 3, 4, 9, 12. For row operation, we write A is equal to I. For row operation, we write A is equal to IA. Here, A is the matrix having elements 3, 4, 9, 12. I is the unit matrix having element, order of A is same as order of I. 1, 0, 0, 1. For a row operation, we change the elements of column 1 as 1 and 0. For a row operation, we change the elements of column 1 as 1 and 0. But here the inversity exists or not. If any one row or more rows having all elements are 0, then the inverse does not exist. Apply row 2. Apply row 2. Replaced by row 2 minus 3 times of row 1. The above expression changes to, there is no change of row 1, 3, 4. Row 2 is replaced by row 2 minus 3 times of row 1. 9 minus 3 times of 3, that is equal to 0. 12 minus 3 times of 4 is equal to 0, which is same as no change of first row 1, 0. 0 minus 3 times of 1, that is minus 3. 1 minus 3 times of 0, that is equal to 1. since all elements are zero, zeros, since all elements are zeros in row 2 of the matrix capital A under operation, since all elements are zero in row 2 of the matrix capital A under the operation R2 replaced by R2 minus 3 times of R1 implies applying one or more elementary row or column operation on A is equal to IA or A is equal to, for row operation we use A is equal to IA, for column operation we use A is equal to AI. If all are zeros in one or more rows or columns of the matrix A on LA side, here the matrix changes to this form. Row 2 contains all elements having 0. Since all elements are zeros in row 2 of the matrix under the operation R2 replaced by R2 minus 3 times of R1 implies A inverse does not exist. Does not exist. Under this operation, the elements of row 2 all are 0. So, A inverse does not exist. Clear? It is a note on elementary row or column operation. Clear? Okay. Write down. Next, shortcut or a direct method to find the inverse of a matrix of order 2. Let capital A be a matrix having elements A, B, C and D. It is a matrix of order 2. It has 2 rows and 2 columns. What is the inverse of A? Place interchange. Place interchange between A and D. That means A will be D and D will be A. Sign changes. Sign changes. Whole divided by AD minus BC. AD minus BC, which represent a determinant. Place interchange and sign changes. Interchange means A will be D and D will be A. Sign changes. C will be minus C, B will be minus B. First, it is the place interchange and it is the sign changes. Place interchange between A and D. A will be D, D will be A. Sign changes of C and B. B will be minus B, C will be minus C. Whole divided by AD minus BC. It is AD minus BC, which represent a determinant. Will be discussed in determinant chapter. Or AD minus BC, which represent a determinant. For example, A is a matrix having elements 2, 3, 4, 5. A inverse. First, the diagonal elements will be interchanged. Diagonal elements means left up to right bottom. A and D will be place interchange. That means 5, 2. 5 and it is 2. Minus and 3 and 4 changes its sign. Minus 3, minus 4. Whole divided by 2 into 5 minus 3 into 4, which gives 10 minus 2 minus 2, which is same as 5 by minus 2 minus 5 by minus, that is 3 by 2 minus 2 and minus 1. Place interchange between 2 and 5. 2 will be 5, 5 will be 2, and the diagonal elements changes its places. Place interchange. 3 and 4 changes its sign. 3 will be minus 3, 4 will be minus 4. Whole divided by 5 into 2, 5 into 2 divided 5 into 2 minus 3 into 4, that is 2. 5 divided by minus 2 is minus 5, minus 3 by 2 by 3 by 2, that is equal to 3 by 2, minus 4 divided by minus 2, that is equal to 2, 2 by minus 2, that is equal to 1. So A inverse is equal to this. Is the direct method to find the inverse of A. Similarly, example 1, example 2, let capital B will be 2 minus 5, 3 minus 3, 7. Suppose it is 5. Imply this B inverse is equal to place interchange of the diagonal elements. That means 7, 2. Sign interchange of the elements minus 5 and 3, that is 5 and it is minus 3. Minus 5 will be 5, 3 will be minus 3, whole divided by 2 into 2 into 7 minus 1 plus 3 into 5, which is equal to, which is same as 29. 7 by 29, 5 by 29, minus 3 divided by 29, 2 divided by 29 is the inverse of given matrix capital B of order 2. Clear? First place change, then place change of the diagonal elements, that means left to right bottom. Then sign changes. In this sign changes of -5 and 3, it gives 2 gives 7, 7 gives 2, -5 will be 5, 3 will be -3, whole divided by 2 into 5, that is 14, minus of 3 into 5, that is plus 15, which gives 29. This matrix into 1 by 29. Whenever a scalar k is multiplied with a matrix, it will be multiplied with all elements. K is equal to 1 by 29, so it gives 7 by 29, 5 by 29, minus 3 by 29, 2 by 29. Is the inverse of this matrix. Clear? It is the direct method to find the inverse of a matrix of order 2, most important, order 2. If A is a square matrix of order 2, then we can find or write the inverse of the square matrix. Clear? Okay, write down.